Good afternoon everyone, we are Group 2 and today I will be talking about reimagining public transport for youth in Singapore. I'm Huang and I will start with the business problem. Singapore's public transport system is efficient but it still runs on fixed schedules. Because of this, we often see overcrowded trains during peak front and underused buses during off-peak periods, leading to wasted time and resources. At the same time, youth mobility trends are changing. Youth commuters prefer flexible and eco-friendly travel options. Yet, despite major upgrades like LTI's 2040 goals, issues like crowding and long waiting times still persist. With COE prices over $130,000, most youth depend heavily on public transport, making improvement increasingly important. Given this, our project examines how public transport can evolve to better meet youth needs. We simulate a youth commuter dataset and use correlation and regression analysis to understand how factors like income, eco-awareness, and weight tolerance influence their behavior. This insight form the foundation for the findings we will present today.
Okay, thank you, Juan. For our data and simulation process, we identify 5 key variables that shape commuter behavior: income, distance travel, eco-awareness, time tolerance, and age. To ground our simulation in real-world patterns, we reference the datasets from the Department of Statistics Singapore, Land Transport Authority, and past economic studies as well. These inform the distribution we used, such as modeling income with a normal range from 1800s to 11,000, and age peaking around 35, which reflects core public transport user. We also simulated a typical travel distance of around 12 kilometers and assigned eco-awareness, time tolerance scores that align with rising sustainability trends and practical commuter trade-offs. Moving to the next slide, we compare travel distance and waiting tolerance. The box plots show that youths who travel further tend to accept slightly longer waiting times, although the variation is quite high. Meanwhile, the histogram review a clear pattern. Most commuters are comfortable waiting around 10 to 15 minutes, and tolerance drops sharply once the wait exceeds 20 minutes. Thank you.
For this project, we constructed a willingness to pay variable to estimate how much a commuter in Singapore might pay for greener public transport options, such as electric buses or more energy-efficient MRT systems. We based WTP on 3 factors. Income, because higher income commuters generally have more flexibility in their transport spending. Eco-awareness, which captures how much a person values environmentally friendly habits in general. Individuals who are more conscious about sustainability tend to be more open to cleaner transport choices. Weight tolerance, because commuters who dislike waiting are usually more willing to pay for faster or more convenient options. By combining these factors with a natural variation, our simulated WTP values range from 0 to around $13 with an average of about $4. Next, we examine the correlation between income and willingness to pay. We found a correlation coefficient of 0.668, showing a strong positive relationship. This means higher income commuters in Singapore tend to be more willing to pay extra for greener transport options. This relates to something we already see in daily life. When commuters, especially higher income individuals, are rushing or dislike waiting, they often switch to Grab, Gojek or Tada, even if the price is much higher. In these moments, convenience becomes more important than environmental values. This tells us that while eco-awareness can influence behavior, it does not always override practical concerns like time pressure. People who are late will always prioritize speed regardless of their environmental attitudes. Overall, this suggests that improving comfort, speed and reliability of green public transport may align better with what commuters actually value. Convenience first, sustainability second.
Finally, we ran multiple regression to understand how different factors influence willingness to pay for greener public transport. From the results, we found that income plays a major role. Every $1,000 increase in monthly income raises willingness to pay by about 93 cents, consistent with what we have seen in Singapore, where high-income commuters already pay more for convenience through ride-sharing apps. Eco-awareness also matters. A 1 point increase in raises willingness to pay by 63 cents. However, this influence weakens when commuters are in such a hurry. In those moments, convenience takes priority over sustainability. Weight tolerance also shows a clear negative effect. Every additional minute of waiting lowers willingness to pay by about 11 cents. This reflects how impatient drivers behavior in Singapore's fast-paced environment, with commuters who dislike waiting often switching to Grab or Gojek for speed. Lastly, age had no meaningful impact. Its coefficient was near 0, and the high p-value confirms the effect is likely random. Overall, this suggests that in Singapore, income, convenience, and commuting habits have a stronger influence on behavior than environmental attitudes, especially when measured.
Okay, so now I'm going to talk about the solution. Our solution is an adaptive green mobility pass. So mainly it's due to the data analysis that we formally done. We will change the price and we will change the frequency of the public transportation. And moreover, we will add a green point system so that we can make sure that everyone will be willing and be happy to use the public transportation. So firstly, it is a smart personalized pricing. As we have formally got from the data that people with more WP and more income will be happier to pay for the green services, and we will put premium green services so that they can pay more and they go to that green services. And it is good because those who are willing to pay can get better green services, and meanwhile, due to they went to another services, so the main transportation services will be less pressured. So that means that will be less crowded, and those people who have the willingness can get what they want, and the others can also get what they want. And secondly, it's the adaptive waiting time guarantee. Because as we have formally got from our data analysis, maybe the core tolerance range is 10 to 15 minutes. And maybe formally our transportation system was 20 minutes or 30 minutes. And then by using this data, we will automatically change the waiting time. Maybe we will higher the frequency of the public transportation and rising it to like 10 minutes so that we can make sure that everyone will be happy to use the transportation because it aligns with the core tolerance range. And thirdly, it's the green behavior incentive, which is a green score, because those who have used the premium or the green services, I think we think that they need to be rewarded with a green point. For example, such points can be changed for couches or the discounts in buying other things, so that we can make sure that it is a sustainable behavior rather than just one time. I think this is as that will be a great motivation for them to keep using such public transportations.
Thank you, Wei Hong. To conclude, our project explores how data can improve young mobility. Our analysts revealed 3 key insights. Young differ widely in their tolerance for waiting. Their willingness to pay depend on behavioral factors rather than income alone. And environmental cautious young respond strongly to green incentive. These findings show that a one-size-fits-all transport system is inefficient. Different preferences require different mobility options. This leads us to design an adaptive green mobility pass. It provides affordable baseline service for everyone, while aligning price, waiting time, and green rewards with individual preference. This is not discrimination. This is behavior-driven matching that reduces overcrowding, encourage low-carbon choice, and keep the system fair.